Okay, welcome back everyone, and welcome to this in series called Experience AI. Welcome to the next lesson, and we're going to look at today, for example, how computers learn from data. So what does it mean? So have a quick think about this question. Is a smart speaker an AI application, and why? Discuss that with the person beside you. Have a little chat with them. For example, you can use a smart speaker like Amazon Echo, Google, or if you're you might use Alice if you're in Russia to do things like answer a question, play a song, or set an alarm. Okay, so you can pause the video here and have a think. Okay, so what are we going to learn today? We're going to come back to that question in a moment. So what we want to learn is that define machine learning's relationship to artificial intelligence. So we've used this word AI quite a bit. We're going to name the 3 common approaches to machine learning, and we're going to describe how classification can be used to solve using supervised learning. Okay, so we're going to create our own supervised learning model. So we had this question back in the first lesson. Spreadsheets, 2 different approaches. Spreadsheets that uses formulas to work out the total cost of a holiday, or an online streaming service recommending films based on viewing habits. Of course, this one is not, the one on the right is, of course, the rule, is the data-driven approach, and the one on the left is the rule-based approach. Yes, the rule-based, the spreadsheet uses formulas to work out the total cost. Data-driven online streaming services recommend films based on viewers' habits. You can't have a rule for every single person because there's just so many people. So therefore, you use this data-driven approach to try and predict what the person's going to like. So some uses of your smart speaker include interpreting your voice commands, answering questions, playing music, and setting alarms. Okay. So a couple of these do represent what we would call AI, or artificial intelligence, that uses things like machine learning, but a couple of them don't do that. So what do you think? Which 2 do you think, or which ones do you think are not? So I'm going to give you the clue. There's two that are and 2 that aren't. Okay. These are all things you can use a smart speaker to do. Which of these would you benefit from a data-driven approach? Which ones would benefit from data-driven? 2 of them would benefit from data-driven. And if you've had a thought about it, you might see, yes, the top 2 are more data-driven approach. There are many ways a person can ask a phrase or a command, and people speak different languages, different accents. So using data for this approach would help. Answering questions can be found using the web search engine. Search engines might use a model to provide high-quality results. They might also help pick which result is most relevant. Playing music and setting alarms is not an AI application. Okay. So yes, your speaker is an AI application, but just because something is an AI application doesn't mean every part of it is AI. When discussing AI applications, you should be specific which uses AI techniques. Okay. So how do models learn? How does a program learn? How does a computer learn? Okay. So we need we need to train it. We need to train it, and we need to do something to help to train. The answer, of course, is data, or data, depending where you're from. And you need lots and lots of data to train your model. Okay. So there's a quick video here we're going to watch on YouTube to tell us what is what is this activity, machine learning.
I keep hearing these 2 terms, artificial intelligence and machine learning. But to be completely honest with you, I'm not quite clear on what the difference between them actually is.
So that's something to think about as we watch this video. There's 2 terms, machine learning, AI, and what do those both mean basically?
Artificial intelligence, or AI, is a term that describes various techniques of designing computer systems to help us solve complex problems. Some AI applications use pre-written rules and lots of processing power. But more often now, engineers use data instead of instructions. Machine learning is a way of building data-driven AI applications where people train a model to make predictions. This training helps the model produce a more accurate output. Machine learning is a part of AI, but it's not the whole of AI.
What do you mean when you say it makes a prediction?
If I asked you a maths question, like what is 2 times 2, you could give me an exact answer. We don't need a machine learning model to help with that. But for a more complex question, like whether your favorite football team will win or lose their next match, you couldn't give me a precise answer. You'd have to make a prediction. You might consider how well the team has been playing recently, the strength of their opponent, or whether key players have been injured. Your answer would start with something like, I think, or maybe they will. There is some uncertainty there because you're guessing. Models trained with machine learning work in a similar way. They can't tell us the exact answer, so instead they're trained with lots of data to make the best guess possible.
How do you use machine learning?
My team works on YouTube auto chapters, which automatically splits a video into different parts and gives these chapters titles. For example, it might split a video of a streamer playing a game into the introduction of the game and clips of this person playing different levels. Videos are complex and there are lots of things to consider. What's in the image, what words are said, and what comes before and after every moment in the video.
Okay, so some key points there. For example, whenever you use rule-based, for example, 2 plus 2, we know what the exact answer is for that. But if you want to make a prediction, you need lots of data to try and predict that. So that's what we're going to do today. So how do models learn? Machine learning is how the models you have heard about are created. So reminder, a model is a representation of a real world context. Okay, so machine learning, a part of AI, is a way of building artificial intelligence systems using statistics instead of writing out the rules in a program. So most computer programs written up before the machine learning and AI were just using rules, and you had to write out all the different combinations, and that took lots and lots of time. Because we use a lot of examples, the data has to do the work for us here. So when we talk about AI and machine learning is part of AI, but it's not all of AI. But the current state of AI relies heavily on lots of machine learning techniques. So traditionally, programs are great at defining steps. Models help solve complex problems that require more than a rule-based approach. So unlike traditional programming where step-by-step instructions are written to solve a problem, machine learning systems make a prediction based on lots and lots of data. Okay. So for example, ChatGPT, there's lots of talk about that. It's just really a prediction model, and it's trained on lots and lots and lots of data, huge amounts of data. And all it's doing at a very basic level is predicting the next word that should come after the word previously. So that's how it seems to be so clever. So the output of machine learning models are predictions based on the data used to create it. So that's why, for example, ChatGPT makes mistakes, because the data that it uses may contain problems or errors. And again, it's working out the probability, or it's predicting what it should sound like. It doesn't actually know what it's saying, but it sounds like it knows what it's saying. Not all problems require a machine learning model, and there is a worksheet on Teams you should try and solve. And you can pause the video here and try that activity 1. So which one of these would use machine learning? Calculating the distance to a star, forecasting air pollution, or identifying animals in a video? You can pause it here and have a go at that. So the first one is probably instructions, because it's a very it's a very exact answer. We can make calculations. The second one could use machine learning to forecast pollution, and the last one could use also machine learning. Okay. So what data would you need for identifying animals in a video? Pick one of these two machine learning. What data would you need to create it, and write your answers into the worksheet. So for the identifying animals in a video, a good example would be to use videos of animals, put them into different categories, and then feed that into your machine learning system. Forecasting air pollution, again, using data from different sensors and seeing what was happened the last time there was a pollution, what caused it, and then seeing how that would feed into your data model. So there's different types of machine learning. I'm not going to, let me see, let's have a look at this video and see what I think.
What are the 3 kinds of machine learning?
There are 3 main types of machine learning: supervised, unsupervised, and reinforcement learning.
Supervised, does that mean I have to watch the computer while it works?
Not quite. Supervised learning is one of the most popular types of machine learning. It trains a model using loads of example data that we already know the desired output of. When the training is complete, the model...
Okay, you can come back and watch this if you wish. I'm just going to continue on and I'm going to show you my explanation of that. So again, as they said, supervised learning uses data that's already been grouped together. So for example, if you wanted a machine to recognize the picture of an apple, then you would give it lots and lots of pictures of apples, and then you would show it another example of an apple, and it would then say, okay, now this looks like the other pictures, so therefore it's an apple. Okay. Unsupervised learning is you just give it the data, and then you ask the computer to group it together, and it could pick certain characteristics. For example, again, if it was something to do with the fruit, it could be groups all the orange colors together, all the red colors together, and then it decides, okay, this is a group, and we call that clustering. Reinforcement learning is where you give it some information, you get what you think is the results, and then you tell it, okay, that was right or that was wrong. So you reinforce the training. So for example, ChatGPT again, the first times it was used, it was like given the wrong answer. So users or people would test it and say, listen, that was the wrong answer, try again. Listen, that's the wrong answer, try again. So you reinforce the learning and you tell it how to improve. So use an agent that has a direct access to the environment. That is a reinforcement. It requires example training data, that is supervised. And grouping data that is similar is, of course, then unsupervised. Okay. Learning by trial and error. What do you think? Again, reinforcement learning. This is how actually Boston Dynamics teaches their robots to walk in such a great way. They just keep trying and trying until they get better. And in fact, they run models in virtual models to try and teach them as well. Requires lots of training data. Again, supervised learning. So these are the 3 main types. Okay, needs data that has been pre-processed by humans. So that means making sure the data is grouped together. Requires lots of training data. Clusters similar data together. It gives you ideas for how to group the data. So basically, you give it the data and say, well, how would you group this? And then it gives you ideas for how to group it. Learn by trial and error. Model needs time to get good at the tasks. So, for example, playing a game of chess over and over again. So therefore, it would require to play the game over and over again until it eventually wins. Okay, so we're going to do this one, which is called classification. Classification is a way for supervised learning to categorize data. Categorize models assigns based on classes. Okay, so for example, we've got different pictures here, and we would label these into the different groups. So orange, banana, apple, and then we're going to put those into the different groups, and we can see there's different examples here. So the next time the computer sees another image that looks like these, it would group it into those different categories. Okay, so we're going to now build our own machine learning model. I'm going to switch over to the handout for this. So let me just check where that is. Here it is. Yeah. So we're going to build what's called a smart classroom. Okay, and we're gonna build be able to control virtual devices. In this case, it's going to be a fan and a light, and we're going to build a very simple model smart speaker where we teach it some commands, and then we test it, we train it, and then we test those commands. Okay, so first thing we need to do is head over to this website here. Okay, and we want to go to your projects. Okay, I've already made one here. I'm going to show you how to start again and make a new one. So you don't click on add new project here. We're going to call it Smart Classroom. Okay, and we're going to recognize text. It's going to be in English. Okay. Oh, I've already got one called that. We just call it P2 in this case then. Yeah. Oh, I can only create one object at a time. Let's do that again then. Okay. Okay, start from here. So we're going to head over to this website called Machine Learning for Kids, and we're going to click on Get Started. So we don't want to sign up or register, we're just going to try without registering. So click on Try Now. Okay, and then we're going to add a new project. And it's going to be called Smart Classroom. Okay, and it's going to be recognizing text. And we're going to hit Create. Okay, so we're going to click on it here and we're going to train our model. Okay, so we're going to give it a couple of different categories. We're going to give it what these called our first bucket. So we're going to create a new label, and the first label is going to be called Fan On. Okay, the next label is Fan Off, and then we're going to have two more, Light On, and the next one, Light Off. Okay, so we have our different models here. So we're going to add some example text here. So for example, turn on fan. It's too hot. Okay. Fan, please. Okay. So you need a minimum of 5 in each of them. Okay. So I'm going to speed up this part of the video and we'll go through these really quickly. Okay, so just before we speed up the video, you need to do the same for the next different ones. So we've got fan on, fan off, light on, and light off. Okay. So you can see, you can pause the video here, and you can see all of my examples. Different words to turn on the fan, turn off the fan, turn on the light, turn off the light. Okay, so once you've done that, click on go back to project, and we're going to click on learn and test. Okay. Okay. Okay, so it may tell you to go back and train, go back to the train page and collect more examples. The more you get, the better. So you need 5. We need 5 examples for each. Okay, so once you've put in 5 examples of each, it says here you've collected 5 examples here. And then what we want to do is press train new machine learning models. If you don't do that, you'll see here, if I do learn and test, it doesn't give me the option to train the model. Okay, so you need at least 5 items in each block. Okay, so train a new machine learning model. Okay, so it's training it now. So basically it's going through all those different text and it's training up our model. Okay. While you're waiting for the model to finish training, try answering these questions. In general, what will help machines to learn better? More examples, of course. Yeah. Which of these would be more likely to be successful? Collect a small sets of examples, train the system, test to see how good it is, add examples, train again and test again. More examples is better, so decide you must need millions of examples. Start collecting massive sets of examples and spend months collecting more. Not sure. Oh, it's ready. Okay, so it takes a bit of time. Our model is now trained, okay, and you can actually test it here. So I can say turn on fan, and it should recognize it, and it says 90% confidence that fan on is what we want. Lights on, for example. 93% confidence that I said lights on. Okay, so once we've done that, you want to go back to your project here again, and we're going to make our smart classroom now. So click on make. We're going to do it in Scratch first. We're going to do another model in the next lesson where we choose a different, we're going to use Python, but for this one we're going to use Scratch. And you'll see here we've got some new blocks that are going to be added to Scratch that will help us to build our machine training learning model. So we're going to click on open in Scratch 3. And now down the bottom you'll see one that says smart classroom. Okay, so we're going to build our model now. So we're going to use an example today, but we're going to show you then you can make your own. So project templates, and you want to type in the word smart, and we want to use this one. It's the easier one, so click on easy. And now we're going to use our commands. We've got our fan here, and I've got our light here. So that's what we want to try and get activated using our commands. So we're going to go to smart classroom, and we're going to take this one first, recognize text label. We're going to drop it in here to each of these, and we're going to go here. I'm going to go here. Okay, so that's our label, so it's recognizing our text. We need to put in what our text will be, because our text will be from here. We're going to go to sensing and then click on answer and drop answer into each one of these. Answer. Okay, and we need to then get our smart commands again, and it's going to be in the labels. So for example, if we recognize the text that's in this group, it's in this value here, then we turn on the fan. Then if we do it and recognize it, then turn off the fan, and do light on, and then of course light off. Okay, so we've talked about these things already, but we already have a loop here that loops forever. And then we enter a command, we ask the user for a command, and if it's if this, so if it recognizes the command we've typed in is based on fan on, then it'll turn the fan on, and so on for the rest. If it recognizes that it's a fan off command or if it's a fan. If it's, so you can see now this is much less code if I have to write if statements that says if the user says turn on fan, then turn on fan. If the user says fan on, turn on fan. So there's a lot more steps you'd have to write. And in this case, you don't have to write that. Okay. So we can press the green button here and see, does this work? So turn on fan. There we go. Our fan is on. Light on. There we go. So you can also give it commands that you haven't typed into the examples. So if I type in, for example, it's too hot, should turn off the fan, or fan off. So you can test it and see what you think. You can do every. So the more information you give it at the beginning, the better it gets. Everything off. So it turned off the light. And I didn't type the word everything into the learning model. So let's try everything on. Let's see, does it recognize it? It turned on the fan this time. Didn't turn on the light, but you get the idea how it works. Okay, so give that a go and see how you do. You can give it some more data if you want to train it. Here, if you want to give it some more data, we can go back to the project. We can go back to train, and we can type in more commands in here and give it more examples, and then your model will get better. You hit train again, train your model, and this is called supervised learning. Okay, so give that a go. If you finish that one, you should try some more projects. There is some more projects on here. So if I close down, open this up. So if I click on projects here, if I go to worksheets, there's lots of different ones you can try. So you can pick one that if you finish, you can try another one and try and see, can you do it? You can change the difficulty here to beginner, and you can decide what kind of type it is as well. So we're going to try and do some of these in the next lesson too. Okay, see you. So that is our machine learning model. So let's try it once more. Too dark. There we go. We turned our light on. If this pops up, don't worry. You can just slide that back down, and we can see our lights back on there. We've got our fan on. Okay. So have a go at that, and I'll see you in the next one.